Morning, one and all present here. Myself, Tanaya Kale, from MIT World Peace University, Pune. So my presentation and research is on Tesla stock price prediction, which I have used an hybrid approach using machine learning techniques and gated recurrent unit models. And I have done this project under the guidance of Professor Seema Patil. So these are the contents in this presentation. So firstly, why the first question that arises is why Tesla only and not other shares or not other stock prices. So talking about Tesla, Tesla is an American electric vehicle and clean energy company that designs, manufactures and sells high performance electric cars, solar products and energy storage systems. It basically focuses on accelerating the world's transition to sustainable energy. And due to this exclusive mission of the company, Tesla's stock contributes very much significantly in the share market, attracting investors to invest and make profit. So talking about the introduction and what exactly has been done in this project. As the finance world or the finance market are fast-paced and there is a need of predicting stock prices to foresee the future, it is both challenging and valuable. So this project focuses on forecasting the stock prices of Tesla using majorly machine learning techniques and few of the deep learning techniques as well. So for studying the historical data, the exploratory data analysis technique is used. Then for building a model, sequential model building is used. And finally, the gated recurrent unit technique is used, which is neural network technique that learns from past data patterns and relationships to make future predictions. So the motivation and background of this project, it lies in the inherent challenges that to predict the stock prices very accurately. So it is important to understand that the stock markets are influenced by many factors such as the industry trends, macroeconomic indicators, which are the data readings that reflect the economic circumstances of a particular country or any region. And one of the most important factor is the company performance. So considering all these factors, it becomes difficult for investors to decide and come to a conclusion whether to invest in a particular company's stock or not. So to avoid or rather reduce this complexity of the investors and not miss any profitable opportunities, this project can be an initiative, particularly for Tesla companies. So I have reviewed 5 research papers which have already done some of the projects related to Tesla stock price. So in the first one, these authors have used KNN, random forest and decision tree. But however, these models had complexity of suitable parameters for prediction. They have also used SVM with radical basis function, which is also known as the RBF function, which computed similarity between two data points based on the distance in feature space that gave values for penalty parameter, kernel coefficient, and tolerance parameter. Then in the second paper, they have simply done sentiment analysis and used the long short-term memory. So they have used historical data of the stock prices and applied metrics like normal error, mean square error, and the mean absolute error. Then in the third paper, the authors have used the machine learning prediction technique using ANN and fuzzy-based techniques. So this paper focused on the relationship between Elon Musk's tweets and the Tesla stock value. So it was basically the real-time comments or the whatever the tweets that came on the social media and the Tesla stock value. So to understand the pattern of that data set, they have used the bag of words technique, which is a natural language processing technique. And then they have removed the stop words and done the pre-processing. And in this paper also, they have used one technique for open, high, low, close parameters or the features that are there in the data set. That is the random forest machine. And again, they have used the evaluation metrics like mean squared error and R squared statistics. Then in the fifth paper, the authors have applied regression models and supervised, semi-supervised and reinforcement learning Also, to be more specific, they have used types of regression models like the elastic net, lasso, and linear regression. And in the last paper which I have reviewed, in this they have used LSTM, random forest regression, super vector, and many evaluation metrics. And the data set that they have used is of 2 years over here. So this is the system architecture of what I have done. So initially, data processing is done, libraries are imported, null values are checked, and the date column is converted to date time format, as there are 4 attributes. Then the next is EDA, that is the pre-processing which is done, and it is a advanced pre-processing where the duration of the data set, which is 5 years from 2016 to 2021. Then the month-wise comparison between stock open and close price is done. And then the trend comparison between the 4 attributes, that is the high price, low price, close price, and open price is done. Then the stock close price is prepared because the prediction is done based on the close price of a particular stock. Then for preparing this stock close price, a separate data frame is created and the close price graph is plotted. Then for prediction specifically, 1 year data is considered, any 1 year from those 5 years data set. Then the close price is normalized, then it is split into train and test, and transformation is done based on the time series analysis for forecasting requirement. Then model building is done. So in model building, there are 2 parts. One is the gated recurrent unit and the loss chart plotting. And then the model evaluation is done. So for evaluation, I have used many techniques like RMSE, MSE, MAE, then variance regression score, R2 score for regression, mean gamma deviation, deviance regression loss, mean Poisson deviance regression loss. So all these are techniques of model evaluation. So talking about variance regression, it measures the variance of residuals that provide how much the prediction is spread from the actual values. Then talking about the R2 score for regression, it measures the proportion of variance in dependent variable that is predictable from independent variable ranging from particularly 0 to 1. And talking about MGD, the gamma deviance regression, it measures the deviation between predicted and actual value using the gamma distribution. And the Poisson deviance, it measures the deviation between predicted and actual values using the Poisson distribution that uses a single parameter lambda. After this model evaluation, comparison of the original stock close price and the predicted close price is done. And from using the random 1 year data and then again splitting it into month-wise data and taking any random 30 days data, the next 30 days data is predicted. And again, to be more specific, last 15 days data is again taken, and then the next 30 days data is predicted. So this is how the data set looks. It has total 5 attributes, and the attribute on which I have worked is the close price, which is the 5th column over here. And the main algorithms that I have used is EDA, which examines the feature, that is the market trends or the patterns, and it identifies the relationships between those. And it also includes the time series analysis, machine learning algorithms, statistical model like regression. Then the second one is the sequential model building, as stock price comes under sequential or time series data. It is important to understand the sequence of algorithms that are built on top of each other to build an accurate model at the end. So decision trees and neural network are are 2 of the sequential model building algorithms used for stock price prediction. Then the main model which is used is gated recurrent unit. So it is basically a recurrent neural network that is used for prediction tasks, and it captures long-term dependencies to handle vanishing gradient problem, which is mostly present in RNN architectures. So in this project, the prediction model is fed with past stock prices as input, and the predicted future prices are taken out as output using the long short-term memory model under GRU model. Then under the GRU model, again, there are two layers that are present and which are added over here. That is the dense layer and dropout layer. So dense layer takes in the flattened input tensor and outputs a scalar or vector. So talking in the context of stock price prediction, dense layer can be used as a final output layer, which takes in the hidden state of the GRU network and produces a predicted stock price. Then dropout is the second layer, which is present, which is a regularization technique used to reduce overfitting in neural networks. So this is a part of deep learning technique that is used. It works on randomly dropping out nodes. That is it, if there are any null values, though there are no null values in the data set that I have, but if there are any null values, it sets them to 0 during the training process. So this forces the network to learn more robust representations and improve the generalization performance of the network. So this is the final output that I have achieved. So over here, variable will change if there are two consecutive prices of a particular stock. So timestamp varies from cursor to cursor, and stock price of different variable timestamp is given here. So as it is a stock price project, there are pros and cons as well. So one of the pros is that it is potential for high returns on investment. Then it has the opportunity to contribute to advancement in financial modeling. It can also enhance the data-driven decision making in finance for the investors. Then it also has the Tesla's influence on renewable energy and technology sectors. Then talking about the disadvantages, the high volatility in Tesla stock can lead to unpredictable outcomes sometimes. Then totally relying on historical data may not fully capture the future market trends. Regulatory changes or unexpected events can disrupt model accuracy. Also, limited availability of high quality data for modeling is one of the disadvantage which affects the stock prices mainly. And the risk of model overfitting due to complex market dynamics can also affect the stock prices at various timestamps. So these are the applications or future scope where it can be used. That is the investment strategy. It can be one of the major factor. Then risk management can also be one of the application, as institutions use predictions to assess and manage risk associated with Tesla investments. Then for market analysis, portfolio management, financial planning, algorithmic trading. So in algorithmic trading, there are the ones who do intraday or mutual funds can use it for quantitative analysis to get the automated trading algorithms to buy or sell the stock prices or make or improve their decisions better. So in conclusion, I would like to say that through this project, I aim to empower investors with valuable tools to make informed decisions in the world of financial markets. These are the references which I have referred to. Thank you.